Hello fellow Scratchers! Welcome back to part 2 of our particle simulation tutorial, and just in time for the new year, right? So we can expect some epic New Year fireworks shows, I bet ya. Last episode we put together some absolutely beautiful particle effects using clones and pen. There's a link to the video in the top right corner of the screen now if you need to catch up. Today's episode is all about collisions, how particles collide and bounce off their surroundings, and how to add some sound too. Boom! Oh yes! This is going to look and sound so good. Guys, I'm super excited to get going, so load up your projects from where we left off in the last episode, and let's get scratching! We'll begin by creating a quick scene for our particles to bounce around in. Don't do this though in the backdrop. Instead, create a new sprite, naming it level. We do this because touching sprite sensing blocks are way faster than the touching colour blocks. Oh yeah, make sure not to fill the background of this level sprite with any colour. Yes, leave it transparent. Any actual backdrop artwork can remain in the actual backdrop costume behind everything else. Okay, position the level sprite at 0, 0 to ensure it's correctly centered on the stage, and then marvel at our project's beauty. Pretty good. You'll note the particles are disappearing behind the level sprite. Sprites always are drawn in front of the pen. For generic fireworks, this might actually be what you want, but when included in games, we are much more likely to want the particles to bounce around when they collide with the scenery. So click into the particle sprite and find the When I Start as Clone script. This contains each particle's movement in a forever loop. And right at the bottom, we already delete each particle that touches the edge of the screen. Well then, we can duplicate that touching check, and then also check for touching level. Give that a test, and well, there's not much to see as the particles were already hidden behind this level, so we can't tell if that really worked. So instead of deleting the particles at this point, let's bounce them back upwards into the air. First, we must remember our particle is currently colliding with the level, so we need to move it back out of the level first. We'll simply reverse the last movement in the y direction. Change y by, with a subtract, and we're subtracting the speed y variable. And then we want to take the speed y and reverse it to bounce back upwards, and also reduce the speed a little so each bounce is smaller than the last. To do that, we set speed y to speed y itself multiplied by negative 0.4. You can play around with that number to experiment with the bounciness of the particles. Perfect! Shall we give this a test? Smash that green flag! Oh yeah, I'm loving this! Each particle is bouncing back and then settling on the ground. Wow, that was easy! The only problem is that after our 300 particles are spawned, we run out of clones, and the fun stops. Until we reset the project, of course. What we are going to need to do is despawn a particle when it stops bouncing and settles on the ground. That is, when the bounce speed becomes really small. We delete the clone. So, after we have detected a collision, we pop in a second if, checking if the absolute value of speed y, that's the speed after the bounce, is now less than 2. The abs ensures we are looking for a speed y value between -2 and 2. And yes, we then delete the clone. Nice! Let's test this baby out. Dropping some particles, and wow, yes, we still get the nice bounce, and then the clones are quickly deleted, and so we are free to keep dropping more particles, and the fun continues. Brilliant! That does look really sweet. Okay, so this may look like it would be enough for most situations, but there is a small problem. Have you noticed it? Our particles collide nicely with the ground, but watch when they hit a vertical wall. They just disappear. We don't have any horizontal wall bouncing implemented. Well, usually when I code collisions like this, I will move the sprite in the X direction, test for collisions, and then resolve them right away if they do, before then moving on checking in the Y direction. But because we need to move in the X and Y together to draw our particle trails, this method of collision detection was not possible. So instead, we are going to do this a bit in reverse. Yes, we've already moved in the X and Y directions and detected a collision here, but we don't know whether this collision was caused by the X movement or the Y movement. Let's see if we can work out which one it was. Start by separating off the set speed Y and the following scripts. Then, after we've moved our particle backwards to the previous Y position, we use an if-else block and check again to see if we are still colliding with the level. Now, if we are not colliding, that's the else branch below, then we know it must have been the Y movement that caused the collision since we're now out of it, so we drop the old vertical bouncing script back into there. But if we are still colliding, then for sure we have bounced in the X direction instead. We'd better put the Y movement back to what it was. Change Y position by speed Y again. And then we undo the X movement instead. Change X by, and we subtract the speed X. And then we can set our horizontal bounce by setting speed X to speed X multiplied by, and this time I'll use negative 0.7, as I want the bounce to be more bouncy for the left and right bounces. Right, so this script will of course be going back in here, but hold on there. We have one more collision case we have not accounted for. What if both the X and Y movements cause a collision? This is the corner case, literally. Yeah, we need one more if check. Are we still colliding after moving in the X direction? If we are, then crazily we have to undo our Y movement, change Y by negative speed Y, and then copy our original vertical bouncing code again from down here to right under the change Y. This way we are now bouncing in both directions after a corner collision. Finally, we can pop this finished script into the awaiting if then. Wow, I hope you were able to follow that. It was all getting a bit scripty for my liking, and it's prime time though to smash the green flag and test them out. Oh yes, looking good. Do you see those cool horizontal wall bounces? That sure is nice. And I do enjoy dropping these particles from different heights, watching how they interact with the walls and the floor. But silent explosions? That will never catch on. To make this truly awesome, we'll need to add some sound effects. What can we find in the default Scratch sound library? A boom? No, that's no good. Explosion? No, nothing there. Pop? Or squash pop, perhaps? Oh gosh, really? Oh, go on then. Let's do this. We should start the sound at the same time we create the clones. In the create particle script, drop in a start sound right at the top. Make sure not to use the play sound and wait, because otherwise the particles won't be cloned until the sound finishes playing. Here we go. Oh my, this really... Oh no! No, this isn't good. Don't hold down the mouse button, otherwise we get a hideous machine gun style raspberry sound. And that's because we are starting the sound afresh every screen refresh. That's 30 times a second. And when you start the same sound, Scratch always stops the previous sound first. And this leads to that machine gun effect until you release the mouse and the sound is allowed to complete. What we'll do to stop this is under the when flag clicked, duplicate the wait until, and have the first wait for the mouse to not be down instead. This means we only trigger the explosion when the mouse changes from being not pressed to being pressed. It's not going to repeat all the time that it's held down. And to balance things out, we'll now up the number of particles in each explosion from 10 up to 100. Cool. Pound on that green flag and let it rip. Oh man, no, what have we created? I think I love it, but I'm not quite sure. It certainly looks cool, just a shame Scratch doesn't have some better fireworks sounds. But not all is lost. The internet is a wonderful resource and we are bound to be able to find some more appropriate sounds there. For example, I quite like the website mixkit.co. You can search for various sound categories like fireworks, and then we get a few paid premium sounds that we really can't use, but under these are some cool free samples too. If you can't access his site, don't worry, I've created an asset project on my tutor account containing these sounds, and there's a link to that in the description under this video. What I'm looking for is a clean sound, a bang, that fades out uninterrupted by other sounds. Of course, we can always cut off the start of a sample, so it's often the last part of the sound that we'll keep. Ah, this one. I really like the sharp snap explosion at the end. Let's download Fast Whistle Firework. You can just ignore that pop-up, the sound will download. Great, so back into Scratch. Then, in the Sounds tab of the particle sprite, import a new sound, and select the Fast Whistle MP3 file. If you've used my asset project, then you can just use the backpack to drop the sound effects sprite into the project, and drag each sound into the projectile sprite one at a time. Before we can use the imported sound, we need to edit it to be just the part of the sound we need. Play the sound first, and you can see that the actual snap bang sound is represented by the second large peak in the wave sample. So click and drag to select everything from before that peak, and then click delete. Test that out to make sure it's what we wanted. Yeah, nice. And then give it a better name. Bang or snap. Right then, clean up. And then we can go back to coding. Switch the start sound to use the new bang sample. Okay guys, now that is what I'm talking about. How cool is that? It makes such a difference having the right sound for the job. And it's surprisingly addictive clicking around the screen and hearing that beautiful crisp snap of an explosion. Now, this may be asking a bit much, but do you think we could add some kind of tinkling as the sparks bounce off the ground? I searched around for a potential sound, and the best I could find is surprisingly in the sparkle category within a sound named Laser Gun Impact Destruction. Listen to this. And there! That little last spark sound. I love it! Download that sample. And now back in Scratch, upload the sound, unless you brought them in from my asset project of course, and then delete everything except that last spark of the sample. You may need to cut a little more off than you think. We want to have the sound begin as quickly as possible, so any delay left before the actual sound begins must be trimmed off. You can always undo if you cut too much. Finally, rename the sound Sparkle. So this sound wants to be heard whenever a spark collides with the level. That would be within the When I Start as Clone Forever loop. Under the first if touching level, start sound Sparkle. Okay, let's go. Are you ready? Boom! And yeah, it's not just you. That really didn't sound good at all. We just get this annoying uniform machine gun of tinkle sounds, and it's not at all convincing. Perhaps we need to just play the sound less often? We could limit the sound to just floor bounces by moving the start sound block down to just under the delete clone block here. Yeah, no, that's really no different. In which case, we could try limiting the sound to only the larger bounces. Surround the start sound with an if and use a greater than operator. And then check if the abs of speed y is greater than, oh, I don't know, try 10. Okay, I don't hear anything now. That was obviously too much. Try 3. Right, the sound is back. And yep, we have less impacts, I think, but the sound is still too uniformly repetitive. I think the real issue then is that we need a mixture of sounds, and the sounds should be allowed to overlap a little, not just restarting like that machine gun issue. The way we do this is within the sound editor, add a 1 to the end of the Sparkle sample's name, and then before doing anything more, make the sound a lot quieter, perhaps 5 clicks of the soft button. Next, we duplicate the sound. It'll automatically be renamed Sparkle 2, which is nice. And then we'll change this second sound by clicking the faster button. Duplicate again and make that even faster again. And then duplicate, but this time we'll make it a bit softer. And then perhaps one more, slower and softer. Great, that should do. Back into the code. So where we are starting the sparkle sound, we'll need a join block. On the left, we write sparkle. That should match the sentence case of our sample exactly, all lowercase for me. And then on the right, we join this with a random number between 1 and 5. That matches our 5 possible sounds. So we can click that and see the different names being listed. Cool, right? So drop that into the start sound block. Here goes nothing. Oh yes, fantastic. That is much improved. The variance in sound is what carries it, I think. Just to note though, the sound on this screen grab that I'm showing you here is not actually as good as the actual sounds you'll hear in Scratch. For some reason, the audio conversion and compression has really rather messed up the high frequency tinkles. Anyway, what I will do is just make each of these sparkle samples a little softer overall. Oh gosh, well that is really as much as I was intending to show you today, but as an added thought, have you noticed how often explosive light effects glitter as they fall? We can simulate that too with a small tweak, but it's up to you whether you include this. See what you think. Just surround our pen down block with an if, and check if random number from 1 to 10 is greater than 3. That will cause us to only paint a random 6 of every 10 particles to the screen. That gives the whole thing a random glittery shimmery effect. There, what do you think? Another tweak that is cool is to make our explosions have a small upwards momentum as they begin. Under the Create Particle script, after setting the particle speed, change speed y by an extra 6 upwards. This then powers our explosion upwards as we click. How about that? I really like that little upwards thrust. Well then, as I wrap up today, I just wanted to give you a quick overview of the changes I made to create this scene. Obviously, I added a simple gradient to the background, and I filled the level in black. Then, in the scripts, I split the main green flag script into 4. One just sets the default variables, but the next 3, they are almost identical, each one creating a forever loop and waiting for a random amount of time before launching an explosion. Now the reason this is cool is that it creates a kind of fireworks show that feels more authentically timed, with gaps and then rushes of explosions that all add to the fun. You'll note I have this find space custom block. This is important. It avoids creating explosions that overlap the level, giving them all a bit of space around them. I've added a medium-sized circle costume, this is called Spacer, to ensure there is room around the explosion to make it look good. The find space block switches to this costume and repeatedly moves the costume around until it's not touching either the level or the edge of the screen. Only then does it hide again and then continue. And that's pretty much it. The particles are then created at the XY position we have just found. I added a third input to this block, only to allow each explosion to use a different sample so that they could overlap nicely, so we get the overlapping sample sounds. I also used a random if to create one of 3 different types of explosion, from small to large, and that special circular explosion too for fun. So, I hope that just shows you some of the fun you can have while playing around with this. Please do submit your projects to the Scratch Studio linked in the description. I really cannot wait to see them and be as creative as you can. What could you use these particle systems for? If you enjoyed watching this tutorial, then please do smash the like button, I'd really appreciate that, and subscribe to the channel so as not to miss the next exciting episode. But that's the end of this tutorial. I look forward to seeing you again soon. Thanks for watching, have a great week ahead, and scratch on, guys.